Hi, today we're going to learn how to build an application programming interface, or API, using Clojure. An application programming interface is a program that runs in the backend, so on a server, and that connects to other servers or to front ends. It's an important building block of the technology of the internet and mobile apps. So learning how to build an API is an important skill if no matter what kind of product you are thinking of developing. You can build an API in any major programming language available: Python, JavaScript. Making the APIs in Clojure, it has a few twists, which we're going to look at. For instance, there is no single dominant web framework in Clojure, but rather we're going to find libraries that we compose or we put together. And sometimes it's hard to tell where one library stops and another one starts. So I recommend that the best way to learn how to build in Clojure is to start small and sort of go bottom up. Add each a library and explore its capabilities, and then sort of move up to the next layer, and until you reach some very interesting, very complete functionality. So what we're going to look at today is sort of a very, very bare bones setup where we have 3 or 4 libraries collaborating to read config files, set up some routing functionality. We'll look at what that is in a second. And then finally expose some content to the outside world. Let's say it could be a mobile app that's trying to obtain a resource, or it could be in our case, we're going to, in this video series, continue specializing this program to act as a backend in a chat service. But really, we could use it for anything. So let's jump in. So in the source code, which you'll find next to this video, you will see a directory structure that looks like this. We have a deps.edom file that contains our dependencies, and then 3 Clojure files which have a CLJ extension. The main functionality is in core.clj. User CLJ has some tools that we'll use to test out our app from inside of Clojure. So that's a very common pattern where we'll produce the application, but also some surrounding tools built into the source code itself. Now you might be wondering, what's the difference between an EDN file and a CLJ file? EDN you can think of as an equivalent to JSON. It's a data container, and CLJ is the source code file. Now it turns out that in Clojure the difference isn't that marked, because Clojure is a Lisp, and in Lisp the programs themselves are data structures. Then these 2 formats are actually a lot closer than they would be in other programming languages. So EDN is a subset of the full Clojure syntax, and most of what you see in CLJ files is available in EDN files, as we'll see. So let's look at that dependencies file. This project has 3 main dependencies. The first one is Reitit, which is a routing library. The second one is Integrant, which allows us to load and unload stateful components. We'll get into what that is. And the last one is Arrow, which is a config file library. The main dependency is Reitit, which is a routing library. Routing is conceptually simple, but it ends up being complex in practice. So conceptually, the routing is all about getting a request for your application to do something or deliver some data, and matching that sort of intent, that request, with a handler function inside your application that will do the work, or read the data from the database, for instance. And it starts out simple, but over time, as your application grows, and maybe you support different versions or different content types, or you have a front end client that needs data sent in one format, then it can get kind of complex. And you might end up having a lot of repetition of code all over the place. Or it might just be slow. One of the main points that the team behind Reitit make while they're describing their library is their performance optimization work that went into it. The next library that we're going to look at is Integrant. This library you can think of as an dependency injection library in other languages. So it's all about separating the stateless and stateful parts of your code, things that you might want to vary between a test environment and a production environment, for instance, and making that sort of boot up process and teardown process as clean as possible, and declaring the dependencies between different parts of your application. So if your web handler depends on a database, which you're going to use to retrieve some data, then there will be, in a data file, we'll expect to see those expressed in some way. And the last library is Arrow. Arrow is a configuration loading library. So again, simple in theory, can get complex in practice. You have secrets, you have other data that's not a secret, you might have different environments, you have things that you might want to load from a file and sometimes other things from the environment. And you want to avoid duplication in your code and so on and so forth. So let's go back to the code. The main functionality is in core.clj. So let's go there. And first we're going to look at the system atom. So this is a data structure that we set up when the program starts and then tear down when the application closes down. What sort of data does that data structure have? Well, the root is in a file called system.edn. And this is going to be loaded by Arrow, our configuration loading library. So this application's an API, so the main part of it is an HTTP server. So here we have sort of a snippet of information about that HTTP server. What's the port and what's the handler function. Now the handler function is a reference to another sort of node in this file. And this, we're gonna look at this IGRef in a second. But you can think of this system.edn as a sort of root data structure that we're then going to sort of make real or hydrate to as our application boots up, and then throw away when the application is finished. And the component that does that sort of hydration is Integrant. And through this init key method, we tell Integrant that the way to hydrate the server /HTTP, which is this key right here, is by running this bit of code. So in this case, we're saying you're going to replace this. So it starts out as being a map of two keys, and then it ends up being an object, which will be the running Jetty server. So the way Integrant works is it gets the data structure, it runs something, and then sort of replaces in place the data structure with the results of running this function. So in this case, we're giving this function the port and the handler function, and then it's returning the Jetty server itself, which is in a running state in memory. And we're to kind of go backwards and tear down that this key, this sort of map key, as we might think of it, we stop the server, right? So it gives us a startup and a boot down process. And we have some other initialization functions. Let's look at them right now. Here's one for our router. So this has been pulled out. So I pulled this out into sort of a top level key in the system.edn, because all of this stuff is very easily accessible to the rest of our application and our tests. So one of the things I want to show is how to test routes out without having to go to Postman or go to curl and sort of hit your API. You can do most of the things that you need to do to test your application very easily just by kind of getting a component out of this system map and running tests directly against it. So the router is spun up using this method, and then we have a ring handler, which is, so the router itself is not even it's all about data. It's not about web serving. So it doesn't know about handlers, which is kind of strange. It only knows about sort of data transformation. This is the particular flavor that the Reitit library kind of has chosen to talk about routing. It's all about data transformation. And then, so in this case, when we use this library, we have to think about two things. One is sort of how we set up this router abstraction that takes us from an outside request to some specification of an inside of like an intent to call a handler. And then we have the ring handler itself, which will be the kind of connect up Jetty, the application server, with our application code. So it's a little difficult to get it, but if you go to the README file and go through this example, it kind of starts falling into place. And we're going to run it. It's easier to understand it when you run it. So those are the three kind of init methods to set up the router. We set up ring, which again is closer to the web serving abstraction, and then we set up Jetty to serve up data. So let's spin them up and see how they work. So I'm going to jack in using Cider, but you could use Calva, you could use Cursive. It turns out I'm already running this. So when you finish booting up your Clojure REPL, it will you should load up the file. There's no side effect in this file. It's just defining functions. In Cider, you can see here's some green bars next to each function telling me that it's been loaded. And so now that we've started the application, we can start and stop the system atom, right? Which is the second step. So first is boot up Clojure and load up the Clojure code into the REPL, then start the system atom. So at the bottom of the file, we have a stop app and start app, kind of the methods in this comment block. The comment block is there just as a sort of user interface for us to interact with the application. So let's run that. Okay, the results of starting the app are shown here in line in my editor. So it's a map, it's a Clojure map. And so all the values have been replaced by objects. So we have the Jetty server, which is here. So these are all Java objects. There's not much to inspect here anymore, but we're going to run some tests on the router itself and the handler in a little bit, which will show you why it's kind of interesting to have them top level in this map. So overall, I'd say that as one of the advantages of this design is that it's kind of conceptually simple, right? You have a map. You think about what are the components or the things in your application you might care about. You put those in an Eden file, which is the equivalent of a JSON document. Then you provide some methods to sort of hydrate those. And then you write stateless pure functions in the rest of your, well, it might not be pure, but most of them will be pure in the rest of your application that will use that data and sort of kind of implement your business logic. Okay, so now we've started our application. What does this application actually do? Well, I'm not going to go through the entirety of the code. but there's a route, an API route, which is described in this data structure in line 45. So this API just says hello back. It's a hello world API. That's not too exciting, but it's something we can build on. So this application, when we get /API/hello request, it will respond with this map here, message hello. This is a Clojure map. It'll convert this to JSON. And how does it know to convert it to JSON? Because there's this format response middleware, and the default response format is JSON. So already we're omitting some code here. We're not serializing this map as JSON and then putting it on the wire. We don't have to do that. The middleware is taking care of that for us. There's a bunch of other middleware which we would have to use in a production application that is secure and then has authentication and so on. So, okay. So the main starts the application. This hydrates the three objects that we have, the router, the ring handler, and the Jetty server. And then these methods here are all described in the documentation for their specific libraries. They're methods setting up kind of the routing table, defaults for what happens if there's a route that we can't find. And it's worth just going through each one of these and kind of getting a high level understanding. But it's even more useful to just try the thing and see it working. And before I try it, I'm going to show you one more file in the project, which is user.clj. So it's really common in Clojure to have a user CLJ file with some utilities. So the comment block that we saw before was like a mini UI built into the source code so that you and your editor can just kind of try things. The user.clj is similar. It just has some more kind of utilities for you. And one of the utilities that I've chosen is Portal. Portal is a kind of nice interface that will show us data structures outside of the editor. Because so Emacs does have, or rather Emacs Cider does have a way of showing you some data structures and sort of navigating through them, but it's not a super nice UI. And also we can't take that out of Emacs, right? So Portal is a tool that will connect to our, we'll send the data from our application and it will just display it for us. It's like a glorified log, data log. And because everything in our application is data, so the routes are data, the requests and responses are data, then we can go quite far with just some nice data exploration tools. So let's open the Portal window. Oop. Okay, so this ran I'm gonna make this a little bit bigger. So this window has an empty explorer, but we can send things to it by tapping values. And tapping is a standard way in Clojure of sending data structures to tools, any tool, usually exploring kind of tools like this. So by executing line 8, anything that I send to Clojure's tap function, which is built in, should show up there. So let's go back to core.clj and let's see, what should we tap? Okay, why don't we have a look? Let's tap some of the things in this comment block. So let's have a look at one of the three keys in the system map. So you have the ring router is one of the three keys in the system map, and we're going to run the match by path function on it to ask right at the routing library, what would happen if I hit the API with an /API/hello call. So in Emacs, I can say tap last S expression. And I'm pretty sure Canva has something kind of similar. And voila, the data is in our Explorer. So here we have some match data that is kind of internal to Reitit. How it's supposed to tell us a little bit of what's happening here when we send this request. So let's have a look at let's see, what can we look at here? Is it template, connect, get? Okay. Yeah, I think this is what we're looking at. Yes. Yeah, we found what we were looking for. So we fished down through the data structure and we found what handler function would be called when we send this request, right? And then the other thing we can see is what middleware is run. And there's a bunch of other things we can do. This is way better than trying to do it in the editor. It's better than like printing it. And we didn't even, so what, now we kind of know that the handler is going to be executed, even though we haven't taken out pulled out the HTTP client and tried it out. So I really like this. So this is showing us the inspector, but also the value of having the ring router kind of top level in this system map. So we can also go one step further. Remember that we had three things in that system map. We have the HTTP server, we have the router, which is just all about matching that string API /hello to the handler function. And now we've confirmed that matches up. Then the next question is, okay, what happens when we actually execute it? You know, as a handler function, let's run the handler function instead of just, we know that it's connected to it. So the handler /ring key has what would be called the ring handler for the application, which is just one step removed from the Jetty HTTP server. So let's call the handler. So we're going to run the same. We're gonna pass it a URI without localhost. It's only a path portion. And let's tap this. Oops. All right. So there we have it, status 200. And we can see what headers we get. And do we see the body anywhere? Yeah, here we go. So it's we see a byte array input stream. We can't really see it. I'm not sure what we can do here. There's probably something we can do to see the actual body, but I think we at least see the response code. Anyway, we could do this in a test. So now we could write a test trivially. Just test that this function returns status 200. That's call the function and then read the return code as data. And we never had to do anything too complicated. So this is a little long for a hello world, but it does show you kind of some moving parts here. That some of the extra moving parts, like having these three libraries, having some of the state set up in that way, is starting to give us some testability to the system, which is kind of interesting. So as your application kind of grows, this will grow a little bit. So if you kind of really get and spend some time kind of going to the definition of these functions, reading the documentation, sometimes it's not that easy to understand. Like Ring is doing caching, and I think sometimes the faster Clojure code is harder to read, but its documentation is quite good, which is great. And it's easy to build these kinds of toys and just test it out, which is kind of my favorite way of learning. So if you can't understand the source code yet, just kind of build a little toy application, test it out, and just keep growing it. And the REPL is great for that kind of interactive development. So we've done all of this, but we haven't seen the application running. We haven't used curl or postman. And so let's go back to the user.clj file. and do a real HTTP request. So I've included a client. Yes, I'm gonna use it, use Clojure. I think this is instead of the shell. I think there's actually very few places where you should need to open up a separate shell and use curl. There's everything you need is kind of the REPL is your shell. This is, you have everything you need right here. Why would you go? So this HTTP client would be the same one that your application uses to do stuff, but it's very easy to use it to kind of debug. So I'm going to tap this and see so here's the result. Now we see the body. So the message looks good. It's a JSON document. And we can see the request headers. We can see the response headers. It looks pretty good to me. I'd prefer this to curl a million times. And that's it. So thank you for going through this example, this basic API example using a modern routing library and some other bits and pieces to help us load our configuration and kind of turn it into data and then turn that into a web server and kind of test it without leaving the REPL. So I hope this gives you kind of a little hint of what some of the possibilities are with this language. And you can download the code and try it and let me know when you do.